Transaction integrity. This is one of the main topics, how the blockchain has the transaction integrity in it, how to maintain the integrity in the blockchain. And this is not easy to understand, but I'll explain you with this diagram so it is clear. So secure and unique account addresses should be there, and how it is done I'll tell you over here. Then the authorization of transaction by the sender through digital signing. So this is basically, it is the authorization of the transaction that the sender has done, so that he or she, the sender, cannot tell at any time in the future that he has not done this transaction. There is a identity stored, or a what you call locked by private key, so that it says that only this person might have done this transaction. So basically, he or she at a later point cannot tell that they haven't done the transaction. So how this works, this integrity and all. So let's say this is Alice and this is a document. Let's say she want to give it to many of her teammates. So now what happens? She takes this document, she hashes it. So she gets a hash value or a hash string. Now she takes her private key, this is her private key, and combines both and encrypts this data or the hash with her private key. Now this is what this combination, the encrypted hash with the private key of the sender, is known as a digital signature. Now what happens? She sends the digital signature along with the document to the network. Now all her teammates get this via the network. So let's say this is Bob, this person is Bob. Now he will get document and also the digital signature. Now what happens? He'll take this document and again apply the same hashing algorithm as she applied. So now he'll get a hash out here. Next, he will take the digital signature. He will take her public key and unlock it. So you can or decrypt it, and you will get the hash. So if both the hashes are equal, then only we can say that this document and this digital signature corresponds to each other. So now this is how transaction is maintained if both the hashes are same. If both the hashes are different, you can know that this document has been changed over the network, or something has changed because the hashes have changed. So like that, the transaction can be maintained very easily, and the integrity also. So you can see now neither the sender can claim that he or she hasn't sent the document, and this guy can also verify that the content has not been modified in the network. Now address of account generated. How is this address is generated? So you have secure and unique account addresses. So how are these generated? There is a 256-bit random number selected. Now this random number is the private key and it is kept secured. Remember that you have to keep your private key always very much secured. If you lose your private key, then your account can be easily taken up and hijacked, and the hijackers may make all transactions and you can't do anything about it. So you have to always keep your private key very safe. Then there is an ECC algorithm which is applied to the private key to generate public key. So this is a elliptic curve algorithm which is applied to the private key which generates public key. Now there is this hashing which is applied to the public key. So you will apply the hash out here to generate an account address. So in short, you will first get a private key, then there will be an ECC algorithm applied on the private key to get the public key, and then this public key will generate an account address. So this is how this whole scenario works of secure and unique account addresses. And this totally becomes the transaction integration, or you can call it as transaction integrity in the blockchain.